Hello. In today's video, we're going to be talking about tree traversal and more specifically, in-order tree traversal. So before we get started, let's talk about what exactly is tree traversal. Well, tree traversal is a way of visiting all the nodes in a tree. Now, this could be a binary tree, it could be a tri-tree, it could be anything, but as long as we visit all the nodes in the tree and process the nodes in some way, that would be considered tree traversal. Okay, so let's talk about the DFS method of in-order tree traversal. And if you don't know what DFS is, I highly recommend watching our previous video on DFS and then come back to this video. So in-order tree traversal, there are actually three main steps of how to do this. So let's say we have a root at D, that node D over there. The three main steps are going to be, number one, traverse the left subtree. So that essentially just means go all the way to the left. And if you think about this in a DFS method, it's going to go all the way down to the bottom left node, and it's going to process that node first. The second thing that we need to do in order tree traversal is process the current node. So let's say we just visited all the left subtrees, and then what we would need to do is traverse or process the current node. That can mean printing it out, processing the data inside. It doesn't really matter what you do, but as long as you process the data. And the final and third main step is traverse the right subtree. So you can kind of understand the in-order tree traversal method as just going from left to right. You're going left, doing the current node, and then doing the right. So you can kind of think about it as a number line. You're going in order, right? Okay. So that's the basic idea of the three main steps for in-order tree traversal. Now let's look at a step-by-step of how this is going to work. So here I have a tree labeled from all the way from A to H. And essentially what I'm going to do is I'm going to have my root starting at F. Okay. So essentially what I want to do is I want my final tree to print out what is the order of the tree traversal. So in the final state, I want the output to be A, B, C, D, E, F, G, H, and I want to have all these nodes visited. Okay, so let's get started. We're going to start on the root, and what's going to happen is we're going to go towards the left. And what is the left subtree? Well, the left subtree is technically this B because it's pointing to the B. And so what does the B do? Well, it's going to go to the left subtree as well. And so what's at the left subtree? Well, the left subtree is essentially this A here. Now at this A, it's going to try to go to the left, but there's nothing at the left. And so it's done that call. So the next thing that it's going to do is it's going to process the current node. So let's process the current node. And so what we're going to do is we're going to print out A. The next thing that we're going to try to do is go to the right subtree. And as you can see, there's nothing there. So what's going to happen is we're going to go back up to the B, and we're going to process the current node. So that's the node call. So what's going to happen? We're going to process the current node, and we get a B. Then what's going to happen is we're going to try to go to the right, and the right subtree is the D here. What's going to happen at the D? It's going to try to go to the left. So that's the C here. The C is going to try to go to the left, but there's nothing there. So what we're going to try to do is process the current node. So processing the current node, we output a C. Next, we try to output, or we try to traverse to the right. And as you can see, there's nothing to the right. And so we're done with the node C. We're going to go back up to the D, attempt to process the current node. So let's process it. And as you can see, it's going to output a D. Then we're going to try to go to the right, and the right subtree is this E over here. It's going to try to process the left. There's nothing on the left. Process the current node, so let's process it. So we print out an E. Let's go to the right. There's nothing to the right. And so what we're going to do is we're going to come back up to the D. And as you can see, this node D here has already finished processing all of its recursive calls. So we're done there. Now we're back up at the B. And as you can see, there's nothing at the B left to do. So now we're going to go to this current node, F, and it's going to try to process it. So let's process it. We print out an F, and so we're done with this node processing. Then let's try to go to the right, and what's going to happen is it's just going to keep going down to the right and finish all the stack calls. So that's pretty much tree traversal with the in-order method. And as you can see, it's kind of going from left to right in some kind of way, right? So it's going A, B, C, D, E, F, G, H. And I've purposely labeled the nodes like this so that you can see exactly how it's going to work. Okay, so let's look at the pseudocode. So first, let's assume that we have a tree definition or a node definition as such. So we're going to have an integer value. So this is the node or the current value of the node. Then we're going to have a pointer to the left node as we've seen earlier. And we're going to have a pointer to the right node. And if you're unfamiliar with this, I highly recommend watching our previous videos on how to make a tree. So this is, in this case, is just a binary tree. Okay, so let's assume that we have this definition for a node. Well, basically, the in-order code will look something like this. So it's going to be a void method. It could be anything really, but as long as we pass in the current node, and we just need to do 4 main things. If the current node is a null, so basically it's nothing, then what we can do is just return. There's nothing to do there. The next things we need to do are just the 3 main steps that I told you earlier. Number 1, work with the left subtree. Number 2, process the current node, and then do the right subtree later on. So it's really that simple. In order cur.left, process cur, and then in order cur.right. And that's all we need to do. Okay, so now let's look at the time complexity. Well, analyzing the time complexity is really simple for this one. Each node is visited exactly once. So what does that mean? Well, that means our time complexity is just going to be O of n, where n is the number of nodes. And that's pretty much it for in-order tree traversal.